On deep linking. First, I would like to introduce myself and what this session is about. My name is Damian, I'm from Berlin, and I'm an Android engineer. I'm working in the Android team at OneFootball. OneFootball is a football news application that is used by millions every day. In this session, we will take a look at modularization. That means we will compare the different approaches. We will take a look at the use cases they cover, where the benefits and drawbacks are. And also we will take a look at common navigation patterns used in a more traditional way and used in a modularized application. And also how these affect our dependency graph. Following that, we will dive deeper into deep linking. We will take a look at what it actually is, how it works, especially on Android, and the benefits and drawbacks. First, we will start with modularization. The question is, why should we actually do it? There are a lot of reasons why we should do it. There are actually too many to name them all, but just to name a couple of them, it forces us to draw boundaries in our code base. It helps us to limit our code access based on necessity, so we don't just make everything available to everything else. It has performance benefits, sometimes, through incremental compilation. And we gain the ability to simply switch out modules. There are a lot more, and unfortunately, modularization is not super easy. When we look at the different approaches, there are a lot of them, so we will just take a look at some of them. The most basic one would be the single module, which is debatable if it counts, but I mean, it's still a module. Even in a single module, you're able to draw boundaries. Kotlin and Java both offer different ways to achieve this, for example, by using visibility modifiers. But moving on to more sophisticated approaches, we take a look at modules by layer. In this approach, we are slicing the app horizontally, which reveals the layers. We have, in this example, a target layer on the top, which is the app layer. Then we have a domain layer with the product-related business logic. We have a data layer that contains our repositories and other pieces, and below that we maybe have an API layer or a database or persistence in general. Each of these layers will be extracted into a module, but the amount of layers and the set of layers obviously vary depending on the application that you're building. In the module by layer approach, it is also easy to switch out the target. For example, here we just added a where target module, which allows us to, instead of building the app for an Android phone, allows us to build the app for a Wear OS device, and we can still reuse the same domain data, API, and whatever else we have module. The next approach is more focused on product features. Instead of doing horizontal slices, in this approach we slice vertically. This will reveal a set of features. If we imagine this as an actual vertical slice, we would notice that, for example, the dashboard module shown here contains everything from UI over business logic and maybe a data or API layer. This is all still in the single module that is exposed here. With a growing amount of feature modules, we kind of realize that we have some duplicated code. So maybe it makes sense to add a core layer with the shared dependencies or the shared code snippets that we are using in multiple features. If we look at the features in an actual application, it also quickly becomes visible that they are not really independent. They are still inter-feature dependencies. If we move to the next approach, it basically combines the vertical and horizontal slicing. In the matrix approach, we would have modules as small and as separated as possible. It's possible for us to switch out single small pieces of these, since in theory, we force ourselves to define clear APIs between each of the layer. And we also draw clear boundaries and borders between the features. Moving on to navigation. Navigation in general, it's guiding the user through the application, plays an important role in how the user interacts with an application. It is the navigation itself, but it also contains things like transitions, backstack handling, and more. In Android especially, we have a lot of different ways to execute navigation. If we have multiple activities, we just start new activities. If we have a single activity application, we can execute fragment transactions, or we can go for a view-based application and simply compose our screen in view groups and other ways. These are not mutually exclusive, so you can obviously mix and match the approaches in your application, but that might make things harder in the long run. The activity navigation is pretty straightforward. We just create an intent, we add a target class, and then we start the activity from a base context. If we are working with fragments, we will encounter fragment transactions. Since fragments are a bit more flexible in general, as multiple fragments can be hosted in a single activity, we are more flexible here as well. So we can do different things. We can add a fragment, remove it, or we can just replace it. If we look at a view composition, there are a lot of different ways to do this. The most simple way would be to just use a view group and remove and re-add views based on our UI state. We can also use frameworks like Conductor or Scoop, which is no longer maintained but is still out there, to achieve this. With so many ways to navigate, there are also a lot of ways to implement the navigation. There are a couple of different navigation patterns. For now, we will focus on the actual implementation of the navigation. That means we will take a look at who triggers the navigation and how the destination is defined. The first way would be an on-demand navigation. If you imagine the example as an MVP project where the activity implements a view that is capable of displaying another view, and the presenter tells the view to do it, it would be pretty straightforward. We just create an intent, in this example, to the home activity, and we start the activity. But what happens here if we have to navigate to the same screen from different views? We would end up with a lot of duplicated code. What happens if the home destination is removed? This would force us to touch every single file that executes this piece of code. And with a lot of duplicated code, that means we have to touch a lot of files. If the same thing happens if we add, for example, after the login, an onboarding step. So in general, this is pretty prone to requiring a lot of changes in the whole code base if a piece of the navigation changes. To kind of get rid of this, we can move towards a global navigator. For this, we would create an interface that maybe exists in a core layer of the application that exposes functions to navigate the user to every screen available in our application. An implementation of the global navigator could look like this. Pretty straightforward. It implements an interface, and in this case, since we are doing activity navigation, we just pass in an activity, create an intent, and then start the intent. If, for example, we would be doing fragment transactions, maybe we have to adjust it by passing in a fragment manager. Or if we do view group compositions, we pass in a root view group to handle this. The global navigator will quickly turn into a bottleneck in the application, as it needs to know about everything, and as it happens in applications, you navigate from multiple places, so it will be required almost everywhere. If we move on from the global navigator and try to split it a bit, we will end up with navigator satellites. The navigator satellites are pretty similar, but they are more feature-focused. This means that we split the global interface into smaller pieces, and each of these contains the methods relevant to, for example, a product feature or a feature module. The feature navigators or satellites can also be extracted into separate modules that are basically floating around next to the actual feature module. The features, if they want to navigate to another feature, now no longer need a dependency onto the feature. Instead, they add a dependency to the navigator module. It's smaller, it's faster to recompile if things change, and it makes things a bit more flexible. But if we look at an actual application, it turns out that still a lot of our features will need to navigate to a lot of other features. So we end up with a very entangled navigation graph between these feature navigation satellites. So in the end, we still create tight coupling between the features. There's also the Jetpack navigation component, in which you define a navigation actions in XML within a fragment scope. Each action has a destination, and these actions are used with navigation controllers to actually execute the navigation. It also offers a visual editor, which is pretty nice if your app grows a lot and you want to take a look at how your navigation graph actually looks like and how it can behave. Summarizing it, navigation is a very important piece of our application. It brings features together, allows users to pass through complex flows. But once a navigation pattern has been chosen and the app is being developed around it, it becomes hard to replace it and to switch to maybe a more flexible one afterwards. So when we think about possible solutions and we think about navigation in our application, it makes sense to kind of set up requirements for ourselves in the beginning before we actually do it. The goal in this would be to create the scalable and flexible navigation. The first requirement is that our navigation is flexible. This means we have to support different types of navigation. We want to be able to do activity-based navigation, fragments, view groups. We don't want to be limited in just strictly going with, for example, multiple activities. At some point, it would be nice to switch over to something else. The second requirement we have is we want our solution to be decentralized. The goal is to allow teams to work independently. We want to avoid having a central navigator file that everyone has to touch all the time. That would create bottlenecks and conflicts. Each module should be able to expose module-relevant navigation to the application. Our solution also needs to be dynamic. If we think about adding features on the fly or turning them on and off, A/B testing, we realize that it'd be nice to be able to register and unregister navigation destinations in runtime. After defining the requirements for the solution, if we look at how navigation actually influences the module dependencies, we can take another look at our previously suggested approaches. So for this, I've prepared an example application. It's very easy, it's just a couple layers, so there's no actual code involved. And we will take a look at the different ways to structure this code base and how navigating between features influences the dependency graph of our actual code. I'm going to skip the single module because that would be a very quick comparison. So we will start with modules by layer. If we look at an application, this looks like the previous example. We have a couple of layers, and we have a couple of dependencies between the layers. It looks pretty straightforward. There's not much that we could improve here, I guess. But if we reduce the dependencies to navigation dependencies, our target module actually is the important one, because all of the navigation destinations are actually in the target module. The app module here would be the one that contains the Android SDK features, so the activities, fragments, and views, meaning all of the navigation destinations are in here. If we apply the same to an app with feature modules, in theory, the app needs to navigate to the features. But since most of the time there's inter-feature navigation happening, this sort of cleanly looking dependency graph turns into a bit of a mess. Going forward from here and trying to fix the issue, we extract our navigation actions and collect them in a global navigator, which means we add a layer on top of the features that can navigate the user to every single state. From here, We can also switch to deep linking to get rid of this additional layer we just added. With deep linking, each feature would define its own entry points in a human readable way. If we now take the same approach and we, instead of looking at the dependencies, we look at how a team or multiple teams might be working together, we realize our goal would be to have the teams work as independent as possible, meaning they have a low amount of conflicts in the day-to-day work. If we have 4 people working on the same code base, A, B, C, and D, and we look at the same example, the area for each person would be the code they are accessing and they are working on. So a module that is contained in a single person's scope would be isolated, and a module that is covered by multiple person scopes might be a bottleneck. In this case, it becomes quite obvious that every single module is shared between all 4 persons. So this would lead to a high amount of conflicts in the long run. If we continue this and look at the examples we had previously, if we move towards modules by feature, in theory it looks like this, meaning the dependencies are pretty clean. Person A has 2 modules to work on, person B has 2, and they are still sharing the same data layer and the same API and database, but these would also be splittable in theory. But if we actually include navigation in this, there's a bit of an overlap happening. So it starts to become more entangled again. The reason is that A is owning team, but still B has to navigate the user to the team module, which means B still needs a dependency on team. So it's not as cleanly decoupled as it looks like on paper. This would also happen if we split our repository, API, and database, for example. If we continue from here and clean up the dependencies a bit, we extract the navigation back into the global navigator, things clean up quite a lot. But we still have introduced a new bottleneck, which is the global navigator. The global navigator in this case is touched by everyone. It is a shared module across all of our scopes. If we think about deep linking, we could, in theory, achieve a proper separation by team, since each module or each feature defines its own entry points. There's no global navigator here that needs to be touched. And of course, we can also split the bottom 3 layers, the repository, API, data. This is just an example, so it's not realistic. Just wanted to show that by doing this, we can further reduce the amount of shared modules in our code base. From this, let's take a look at deep linking, which means take a look at how it can help us achieve our goals and what issues we might face. First, a deep link. A deep link is following the URI scheme. It's well defined. The scheme and authority part are required. The rest is actually optional. We are already using links in a lot of use cases. The most well-known one should be the web. They can have different schemes. This, for example, maybe might look more like an actual deep link. This would be leading into my app and pointing towards the dashboard feature. We can create deep links in different forms and shapes. We can use all parts of the URI scheme. In this example, we are taking the user to a profile and we are passing on the ID of the target user. In this example, we are using HTTP as a scheme. This is still working if we talk about deep links. As you can see on the bottom, we are registering the application to receive an intent that is going to view our website. In this case, it's http onefootball.com. So if the user is receiving a link to onefootball.com, we will be asking the user if the user wants to look at it in our app or as a fail-safe, go to the website. This also means that if we have multiple users and multiple versions of the app, and some versions might not be able to display certain deep links, we always have the fallback that the users with applications not supporting it will go to the web. Deep links are not the perfect solution, of course. So for example, we have a couple of issues. What if we need to transmit arbitrary data, like user or user input? If we want to see a deep link as a standalone resource, how can we manage the backstack, for example? And who is supposed to know about the deep links and how to parse them? If we take a look at, for example, transmitting the data, we quickly notice that we can't attach data objects. All we have is the URI. In an Android app, we could add a bundle to our intent, but this doesn't work if we see a deep link as a universal layer. So the app state and the data to be displayed need to be identifiable through the URI. It's basically the same approach as when we are navigating to a website. If we take a look at the backstack, imagine the following scenario. We have a football player profile with a deep link. But now we have two different pages that can direct us to the profile. The user can come from the team page or the match page, or through an external source, through the deep link. After looking at the player, the user wants to go back. But since the user came from a deep link, what does back actually mean? Usually back means back to where the user came from, but since we want our deep links to be standalone resources, we may not know where that actually is. There's no backstack present. A solution to this problem is to add context to the deep links. In this example, we have different team links depending on where the user came from. We have a deep link if the user came from the team page, and we have a deep link if the user came from a match page. And both of these carry the information needed to identify the previous state or the previous page. If we take a look at how we can process deep links, we need an entry point. In an Android app, this would be an intent filter. The next thing depends on the type of navigation that we want to execute. If we have a multi-activity application, each activity can define its own intent filter. We can have, for example, just a host and a scheme, and this should be enough in this case to identify, okay, we are looking at a profile. If we have a single activity application, we need to execute fragment transactions. This means our host activity needs to define an intent filter and to be able to parse the deep link and somehow pass it on to someone that can execute it. The same thing happens if our app is relying on view compositions. We also need a host activity which defines an intent filter and parses the deep link. So moving towards a single activity application, we have to process the deep link on our own, which means we need a single activity that can handle all deep links that are targeted towards our application. To actually trigger the intent filter, this would be an example. We just send an intent with the deep link as a URI. This would be the same as if the deep link is triggered by a third party, and there's not much we are transferring. The content is identifiable by the URI we are passing. In the catch-all activity, we can then parse the deep link and forward it to, for example, a handler. In this case, I added an abstract class that we can define the handler or where it comes from at the point where we implement it. The activity itself just opens the intent, which was used to start the activity, and then accesses the data and passes it on. In this case, the deep link handler has a list of deep link processors, which would be supplied dynamically from the features. Each of these checks if the intent is the right one. It checks for some flags, and then it can execute the deep link, or it can return the proper action if it needs to be a fragment transaction, or it can trigger the view composition, or else. The handler would simply loop over all the processors that are available and pass the deep link to the matching one. So each feature can expose one or multiple processors. This would basically be an implementation detail if your feature also has a single point of entry, or if you have multiple points where the feature can be entered through. There are also a couple of libraries that take care of this. For example, Deep Link Dispatch by Airbnb. It is annotation-based. It's pretty declarative. It's easy to use by just adding an annotation to an activity. It allows you to specify variables. And it also requires us to register a catch-all activity in our Android manifest. The navigation component can also handle deep links. With the navigation component, it is also pretty easy. In the end, we just add a deep link tag to the fragment we want to expose. Then we add the navigation graph to the XML, and during build, it will be replaced with matching intent filters that expose our deep links. Continuing from here, we will take a small detour towards dynamic features and how things will change when we actually do this. If we look at dynamic features, they are a quite significant change in our dependency chain. Dynamic features are basically the next step after app bundles. The app bundles decouple bundled resources and create smaller APKs that are targeted towards specific device configurations and users. The dynamic feature modules, on the contrary, would decouple code modules, allowing the user to install modules in runtime. This means that every user can simply install features they actually want to access or that they actually need. In our example at OneFootball, we have used this to remove a video player from the example, from the application, for example, as it was a pretty big dependency and most of the users didn't actually use it. The important part here with dynamic features is that we are inverting the dependency of the features. In a standard application or in a traditional application, the target module, in this case app, would be on the top. In this case, newsfeed is a dynamic feature, which means it is no longer below the application module. In this case, the newsfeed module is depending on the app and is injecting its functionality into the application, rather than the application knowing about the feature and just using and exposing it. But even with dynamic features, we still need to somehow navigate to the features and between the features. If we look at the traditional navigation approaches, and we keep in mind that with dynamic features, we don't know if a feature is actually loaded unless we check it. We need to go for example, a reflection-based approach, as most of the code is unreachable in compile time. Reflection might look like this. If you want to start an activity, it becomes quite ugly at some point. This adds new requirements to our previously defined ones. The navigation now needs to be implementation independent. Destinations need to be optional, meaning our app should be able to handle it gracefully if a navigation destination is not present. It shouldn't just crash in the best case. This also applies to other types of navigation. This would be an example of a fragment transaction if we execute it based on reflection. The fragments now, they still need to be instantiated somehow. And this also becomes quite ugly. Now, if we think back at the different approaches to navigate, we need an implementation-independent way to navigate. And here, we can come back to deep links. The deep links can be resolved by any dynamic feature module that implements the functionality. If we think about other benefits we might have, if you are working on an application and you're doing A/B tests, it is very easy to just switch out the modules, since both of them are not tied to the actual application. The coupling here is done through the deep links, which is, as mentioned, independent. So if you execute an A/B test, it doesn't matter which of the two or multiple modules is loaded, as long as they all know or expose the functionality via deep link. The same happens if we are iterating on a feature. It's easy to just add a new module that serves the deep links. There's no need to change interfaces and implementation details in the target or in the base modules. And of course, since we talked about conflicts between teams, if our navigation is done via deep links, we will pretty much reduce this, as there's no need to touch any of the bottlenecks anymore if you just want to add or remove a navigation action. Next up, I've prepared a slide with a couple of resources to help or guide through the process of modularization and making the navigation stack a bit more flexible. Here's some information about deep linking, navigation patterns, and of course, dynamic feature modules. There's, I think, a well-known example from GitHub, but nobody knows how to pronounce it, which shows dynamic feature modules and how they can be used in an application. That's it. Thank you very much for joining.